Vice Chancellor of Atria University and the former Secretary of Earth Sciences. You cannot think of a better person to tell us about why this year's onset was unusual. Okay, he has done a lot of work on onset and related work. So I request Rajeevan to make a presentation.
Thank you. So I'll be giving a brief talk about maybe 20-25 minutes about this year's monsoon, and also I will discuss about what do you mean by climatologically our normal monsoon looks like. So you can interrupt me and ask questions if you have. So this is the climatological monsoon onset and progress, which is done by IMD recently. So earlier IMD used to have a this kind of charts, which was prepared in British time, 1940s. By that, that's basically meant for aviation. It was there for a long time, so that recently we revised it. And you can see that around 22nd May, monsoon comes over Andaman, and by 1st June it covers Kerala. It enters into Kerala, and by 10 June it covers Bombay, and then it goes up, and by 8th of July it covers the whole country. So there's a difference between how the monsoon progresses along the west coast as well as in the eastern parts. You can see the west coast is just a northward propagation, northward movement, and from east to northwest is basically a kind of a northward propagation. And so this characteristic you should know. And normally the onset over northeast is a little later, a few days later than onset over Kerala. But this year over northeast it came first, then it came in Kerala. Okay. So earlier, now question is how. So there are two onset in literature. If you really read research papers, some people talk about onset over Kerala. So we call monsoon onset over Kerala MOK or something. So that's most of the papers are related to the onset over Kerala. But there are plenty of papers which talk about the central India, when the monsoon came over central India. That's the core region, monsoon core region. So there are different. So when you read on onset papers, you should know which they are referring, whether it's monsoon over Kerala or over central India. And IMD basically follows the monsoon onset over Kerala. And the early days they used to Anandakrishnan's famous criteria. So that was based only on rainfall along the west coast. And they identified about 7 stations. And up to 10 May, if any 5 out of 7 stations report 1 millimeter for 24 hours for 2 consecutive days. The second day is considered as a monsoon onset day. And you can see very interesting is it starts from Colombo and goes up to Mangalore. The question is why the Anandakrishan took the so larger area, stations from a larger area. The purpose is for the onset Kerala normally gets a lot of thunderstorm activity. There's a lot of moisture, advection, a lot of temperature heat, surface heating. So convective activity will be very normal before onset. It's not really over any part. Before monsoon onset, there's a lot of convective activity. Now, question is how you differentiate thunderstorm activity from actual monsoon. The thunderstorm activity means it may not be spread over the whole from Colombo to Bangalore. Okay, unless there's a monsoon current. So that's why he took it from Colombo to Bangalore to avoid the thunderstorm rains. And the only thing is there's a criticism 1 millimeter is too small for a monsoon rain to report, and only a few stations, and that's some of the. And also it is based only on rainfall, so we did not see anything else. But monsoon, of course, people are more worried about rainfall. And for example, if you say that monsoon circulation has come to the people in Kerala, they don't understand unless they really experience the rainfall. So rainfall is very important, but the criteria is, should have some other. So there is a literature, if you see, there is a concept called bogus or double onset. What will happen means when convection starts, for example, associated with a tropical cyclone, that really happened this year. There was a cyclone in May. So it heats up the whole atmosphere in the Bay of Bengal. There's a lot of convective heating. So along the west coast, winds will get strengthened, and then there will be a lot of rains over Kerala. Okay. So normally, so if you really close your eyes and go with the Anandakrishan's criteria, you will declare as monsoon onset. Okay. So that's we call bogus or double onset. So, and this is a typical paper by Flatue et al. In 2001, and 1995 is a typical example. This year also it could be a good example. And the thick line shows the SST. It peaks up and cools once monsoon comes, it cools up. But if you really see the wind and specific humidity, you can see there are two peaks. One just before the bogus onset, then it comes down. Then real onset comes much later. Okay, there will be a gap about almost 10 to 15 days, every 2 weeks. So sometimes if you don't see anything else, then people will assume that the first peak is associated with the monsoon onset. But it's not really monsoon onset. But once you declare it, and after a few days, there will be no rain in Kerala, there will be completely dry. Like you can see clear skies, people will laugh. People start laughing. So so this bogus onset was a crucial. So when we revised our criteria in 2009, which is still being followed by MD, and we did a big exercise, and we took about 14 stations, which are only 7 stations, and these are all important stations are reported every day. So operationally it is possible. And we there we put a condition of 2.5 millimeter instead of 1 millimeter day. And we said 60% of the 14 stations, this is also from south to up to Mangalore, for at least 2 days. The onset is declared the second day, provided the remaining also is satisfied. What we are trying to see is we put conditions of zonal winter, basically the monsoon westerly flow. In bogus onset, we normally see this monsoon, even the the westerly flow is strengthened. It is not very deep. It is only the lower troposphere, the monsoon, the western done. I cannot use the word monsoon. The westerlies get strengthened. But real monsoon onset comes, the monsoon depth of monsoon westerlies goes up. It goes up to 600 millibar. So that's why I put westerly wind should be present from surface to 600 millibar. HPA, average over so it's close to equator. And also the wind speed should cross so. And also we have put one more condition of OLR. There should be associated with a lot of convective activity, a lot of cloudy and rains. So we put some 200 watts per meter square, and based on insert derived. We put insert derived because if you take 2 satellites and derive OLR, there could be differences up to 5 to 10 watts per meter square. Okay, so based on that, what are the climate? Also, the monsoon onset dates time series is typically by MD, defined by MD, and from 61 to 2024. The earliest onset came on 16 May of 1969, and latest on 18 June 1972. Thus, if you really plot a small trend, it's a small trend, but it's not statistically significant. So if you see the latest years, you can see that it's all after 28 May into June, it is coming. And this is just a histogram, shows how the days are, onset days are distributed. So mostly a Gaussian distribution, but a little skewed towards right. So that means more days just after 1st June. And this I borrowed to it from Arindam. So this is how the convection and wind flow changes with the onset. Top one is the 3 pendant, 15 days earlier to monsoon onset. How it looks like. You can see that there's a classic flow already starts. Some areas coast of Africa starts, but monsoon flow is very weak, and rain is, especially Arabian Sea, is not very strong. It's very little activity. But a lot of good activity over the Myanmar coast, and by that time monsoon will come over that Indonesian region, Malaysia, and all will get monsoon by that time. Then you get slowly the classical flows get strengthened. Westerly, the 2 pendant, you can see that westerly flows get strengthened, and also the convection over the east, Myanmar coast. And the onset period, you can see that beautiful classical flow and strengthened monsoon flow. And also, so monsoon onset could be something during the monsoon onset period, something could be, we can draw something like this. That's a climatological picture. And if we really see the OLR 2 weeks before, this is the OLR, and before onset, most of the convection is south of Indian continent. A lot of activity in the southeast of North Indian Ocean. And 2 pendant afterwards, you can see that a lot of convective activity along the coast as well as. So this is the way monsoon progresses. I'll show some beautiful results from. So this is how it looked like 850 millibar when you average about 20 years of monsoon onset dates. You can see beautiful cross-sectoral flow and wind flow south of Indian subcontinent is very strong. So there's a large shear north to south to north shear. There's a big shear. Shear is very important in monsoon circulation. So this is at 850. This is at 700. So still, it's very cross-sectoral flow. It's not very seen in 700 millibar, but you can see the monsoon westerly flow. And also very important is this. So IMDB meteorologists, we see this here. You can see that this westerly turning into easterly. So you can draw a shear line like this. So this shear line we look for in onset. So onset, when during the onset period, we see this shear line, which is also seen in the 600 millibar. Also, you can see the shear line. So we look for the shear line. Basically, it is nothing but the northern movement of ITC. ITC comes to there, we get a shear line. And so this is at 600 millibar. And you don't see much cross-sectoral flow over eastern parts of Africa. This looks like how the visible water content during the monsoon onset period. You can see that most of the large visible water content is seen over eastern parts of Indian Ocean and little bit over Kerala coast. But if we go north, there's a large gradient of visible water content. So when monsoon onset happens over Kerala, central India and northeast India is still very dry. So that's very important. And also, if you really see the winds, you see 850 millibar over northern parts of central India, northern parts of India, still these are westerly winds. And this is how it looks like the onset monsoon rain. And so you can see that beautiful ITC kind of rain band from west remains to Kerala coast and Bay of Bengal. What is more important is this one, the southern hemisphere. We call southern hemisphere equatorial trough. So when monsoon onset happens, southern hemisphere equatorial trough also is equally active. Then we find that if it really starts moving north, the southern hemisphere equatorial trough should weaken. Then it will start weakening. But onset during onset period, both the northern hemisphere equatorial trough, so-called ITC, monsoon trough, we call, and southern hemisphere equatorial trough, both will be equal.
What is the reason for the southern hemisphere and northern hemisphere symmetry equatorial trough during onset?
Pardon?
What is the reason for the southern hemispheric trough?
That is, southern hemisphere, even if you take a climatology, always you see two troughs, one is in the north, one in the south. If you take annual average, you see more of trough position in southern hemisphere, not in northern hemisphere. So southern equatorial trough is very active. And most of the tropical cyclone forms during January, February, December, and on this equatorial trough. So that will be active till May, June. Only during monsoon season it becomes less active. And it will become active when again break comes.
I was thinking that so it is for symmetry and monsoon onset over Kerala is connected into several times.
Yeah.
So it could be just a replication that or just because because India has already passed the maritime continent and the reminiscence of it, so that is 10 to 20 meter more which goes westward, would be making the symmetric that trough in the west, north and south.
Quite possible.
Yeah, okay.
Okay. Some people even study the southern hemisphere how strong during April, May, and give a forecast for monsoon season rainfall. So there was a scientist in IMD. He used to send it to Prime Minister also every year. The southern hemisphere trough was very active this year, so monsoon rainfall will be back. So I used to get response from recommendation from Prime Minister's office. Please cancel these forecasts also. Okay. He's Ongari Prasad, Dr. Ongari Prasad. He's still active. Okay. So this is a very good paper, Parker et al.'s. I think you should read this paper. It's a quarterly journal. That's on the climb, and you see this how the rainfall looks like on 1st May, 16th May, 31st May, 15th June, and these black lines are basically climatological onset dates. And you can see that how beautifully the rainfall pattern changes. And the 30th July, 15th July, monsoon onset happened completely. It covers whole country. This is the same thing, but in terms of frequency, in terms of percentage of rainfall, 2.5 millimeters. So it gives the same message. So what is very interesting is, as I told that here the west coast it is basically north layer, and from here it is all from this southeast to northwest. And if you really see the 600 millibar flow, which I showed earlier, winds are like this. For example, I'll show it later also. So the onset happened just across, just against the mean flow in the 600 millibar middle troposphere. This is seen here. You can see that up only 600 millibar, sun 750, 850, 925, and the left hand is 31st May. 15 June and 15 July. You see how monsoon humidity as well as horizontal wind changes with the monsoon onset. You can see that it was very dry, especially in the middle troposphere by 15 June, sorry, by 31st May, but it slowly picks up. So monsoon current just moves against the mean flow over northwest India. And there are definitely, as I told that some people define monsoon onset over central India, or the whole country, something like that. So this is a famous paper, Fossil. He used a vertically integrated moisture transport average over a particular region, especially central India. And he can define, based on that, we can define mean onset date and mean withdrawal date. And if you really plot central India rainfall, daily rainfall, mean climatic rainfall, just to overlay it, it looks like similar. So basically, it's the rainfall. And so for him, 4th of June is the onset date, and 7th of September is withdrawal. So it's too early, this calculation. And another definition is by Goswami et al. He used the average temperature between 200 and 700 millibar. And over the two boxes shown here on the left-hand side, and the top line, the black line, dark line, it shows how the temperature changes. So you can again define onset and withdrawal. Starts from here, goes to the positive, and comes down. So basically, the temperature difference between the southern portion, southern latitudes to northern latitude. This is one of the definition of monsoon onset, but doesn't say anything about monsoon onset over Kerala. Kerala onset is entirely different. I'll come now 2024 monsoon. How it looks like. This is the onset date for this year, monsoon 2024 onset and progress. 1920 May came a little late, and here monsoon was stuck up here for a few days. On 1st of June, they declared for Kerala, and then it started moving a little bit. Then by 10th, it started covered almost Bombay. Then it got stuck up. Then up to 24th June, from between 10 and 24th June, there was no progress. Monsoon was stuck up. And here also, monsoon was stuck up somewhere around 30th May, then 31st May. Then it took almost 20 days to move from east to west. So, and I'll show what really happened this year is in one beautiful hormonal diagram of precipitation average between 75 and 90 degrees east. And this is the latitude, and this is the dates. They start from 14th of June, 14th of May, 15th of May. And you can see that I will explain. So this will explain so far what really happened. This was the first spell of little northward movement, propagation happened. And then the cyclone Rimal formed, and it moved here. So this is nothing but it's basically cyclone. It's not the whole so-called IT system. It's only cyclone. It moved. But here convection was there because it was persistent for a few days. It rained a lot. Then the second spell came. This is a weak monsoon onset spell. This is the period when IMD declared monsoon onset. And you can see again northern propagation was there up to maybe around 12 degrees or so, but it was very weak. Then there was a big prolonged airlift. There was nothing, no activity. Then again the second northward propagation started somewhere in 22nd of 20, after 20th of June. And now it started, it moved, you can see that it moved even up to 25 degrees And this is the active monsoon now, which is happening now. So this is the way monsoon really progressed so far in this season. And the first when Remel came, what was the circulation 850 millibar? Is a composite mean between 2 days, 24. And this was where cyclone form. And you can see south of that there's a lot of convective activity. And you can see the westerly flow is there. It's not very strong. Then and this was the rain associated with the Remel. You can see it's not a very typical onset pattern. And initially, we people all thought that when Remel came and it was hanging there, we all thought the rainfall associated with that is basically a kind of onset. So we all thought it may be earlier onset, but it's not really. So. And of course, there was a sheer kind of so you see here, this area and this area, so you can draw a shear line, but it's not really the monsoon shear line which we normally see. This is the Remel, and this is when really monsoon onset came on 21st of June. You can see that very interesting is monsoon, the classical flow is not at all strong. It was not very active. Of course, the studies are very strong here, but you can see here it's not really westerly, it's all northwesterly here. And also you get a kind of ridge here. So I mean, east of this ridge is basically it's a divergence. Not much convective activity, but rain little bit for Kerala. It was a very weak rain. And my brother in Trivandrum called me, you declared monsoon, this is skies are very clear. So, but I said it must have rained somewhere else. So this is this is same day. It's on to 700 millibar. But you can see very interesting is this is not really confusing. So you can see there's no classical flow. There's a classical flow is there a little bit, and you can see a lot of studies. But a typical synoptician like me in the MD, you see this shear. Here was there. There was an instrument here. And even 600 millimeter was there. This is the 600 millimeter. You can see that there was a. It's not a east to west, it's kind of north east to southwest kind of thing. So this is not a typical textbook pattern of monsoon onset this year. And but IMD defends that well as a declaration of monsoon onset on 1st June is true. So this is a rainfall pattern. This looks like very impressive. You can see the southern hemisphere, as you know that it is seen as a lot of activity. And there's a east-west orientation of rainfall activity seen there. Now, last part of his monsoon had, I told that from between 10 and 24, there was not much progress, not only over along the west coast and along the east part, so from Bay of Bengal to northwest of Rajasthan. And also told that these are two different patterns. So, frankly speaking, the physical mechanism in which monsoon progress here and monsoon progress here are different. Okay, this is basically moving IT system moving north, or the westerly trough forming over Kerala coast and moving north. Whereas these are low pressure system depressions forming over Bay of Bengal and taking the monsoon inside. And it moves along the monsoon trough. And this is the monsoon. As I told that there was a hiatus, is kind of a pass over the northern parts of Maharashtra about 14-15 days. And another one good example I can show in 2010, and you can see that monsoon has gone up to northern parts of Maharashtra around 18 June. Then took next is on 3rd July, so almost 10-12 days of hiatus. So what I did is I did an exercise. IMD has this monsoon onset charts from 61. So I took the monsoon onset charts and tried to understand how hiatus works. So we concentrated really on the western parts, how the monsoon is progressing. So we could make a time series of hiatus, how many days of hiatus is seen. And this is an internal variation. And mean is around 6 days in a year with a standard deviation of 3 days. And what is beautifully seen is a trend. It's positive trend or the increasing trend. So over the, after including 2024, I'm very sure that 24 value must have influenced the trend, but otherwise also you can see that it's an increasing trend. It's a significant at 99% level. So nowadays we see more and more higher tests happening during the monsoon progress. The question is why? And especially the first question is what really, this is again I borrowed from, sorry, Arindam gave me. And what he did is took the rainfall of central India and found out the years in which the central India rainfall onset was late and early. So those years, how many higher tests were there? So, and it very clearly says that when onset over central India was late, there were more higher tests. And for example, there's a late onset, there are 95 in 28 years. And in early onset, high tests still happen, but number is small, only 36 in 25 years. So statistically, it is very significant. So higher tests in the monsoon progress really caused the delay in monsoon onset over Kerala. In the beginning, I told that monsoon onset maps, climatic maps were revised recently. When we revised, we found that now the new dates are almost 10 to 12 days later than the climatological map which we had earlier. That means nowadays monsoon onset happens much later over eastern parts of central India. So the delay in monsoon onset over central India now in the recent years can be explained by more increasing trend of higher test level schools. One possibility, because it's all related. Well, it is very easy to interpret. When monsoon goes and stops there, unless it moves, certainly they won't get rain. So if there are more frequent higher tests, obviously the rainfall, the onset of central India can be delayed. Somebody is asking question. Yeah, this year, so we started addressing it, what really happened this year. So I took that higher test days and tried to plot. This is basically moisture flux Q into V vector. And 600 millibar, 700 millibar. You can see that especially 700 and 600, the beautiful northward from northerly flow with the dry northerly intrusion is seen. It is also seen in the same thing. It's a Q and V we plotted together. It also gives the same information. There's a lot of dry intrusion of this thing. And there's a famous paper by Butt, but it's not here. So 2006. So he studied the 2002 drought. And July 2002 July was very famous. Almost the fishings was almost 50%. We tried to understand what really happened. So at that time, they had Ormax data, there were ship observations were there. And the paper was very famous. So I tried to, so there they showed that there were a lot of dry intrusion. And that was the main reason. And there was inversion over the ravines. And so I tried to use it, same analysis and try to do it with the reanalysis data. The red is during the higher test time. This is relatively. And the blue is basically the recent few days. You can see that middle and upper troposphere was completely dry during the higher test days. And so drier intrusion is pretty much seen. The question is, what causes the dry intrusion? So it could be because it's coming from north, something related middle altitude could be one of the suspected reasons. So I'll show one more just a plot. This shows during the higher test how 200 millibar vector anomalies were seen. Beautiful Rossby wave you can see. You can see the kind of a anticyclonic flow and beautiful cyclonic flow. And a lot of large scale western intrusion over northern parts of India. This is a very typical pattern in any drought year or any break. You take any break and try to compensate 200 millibar bits, you will get this kind of Rossby wave pattern. I'll stop here. I'm not sure whether this is the only reason for the intrusion here and also the higher test. So the subject of higher test monsoon progress is a gray area where we need to understand more because it really affects farmers. When monsoon onset happens in Kerala, farmers over Uttar Pradesh, Madhya Pradesh, they wait for sowing with all seeds, everything, and they also make the paddy fields, everything correct. Appropriate for the sowing. But monsoon doesn't come, they're stuck up. So, and question is whether this, another major question like a forecast like me, whether it can be predicted. The hiatus can be predicted. These are some of the questions which we need to answer. You are the right person. I've become very old now. Wish you all the best. Thank you.
Okay, any question?
How many questions? Maybe.
No, I just wanted to know what is your take on the rest of the monsoon?
Difficult question. I will put it down as bad. May not be a top. How is it? It may not be 106 could be a goal now, but La Nina is not really getting warm. There's a delay in La Nina formation. But next year, 2 weeks forecast I saw in December up to the estimate forecast. It's pretty good. This one low pressure system is forming on 70. And so that will bring a lot of rains. July will be good. And La Nina forms also, second half is normally still good. And say for example 2018, 19 were La Nina, September really picked up. So we should expect good rains in September. So I personally feel IMD's forecast will come correct. To 106. May not be 106. 104. It's above normal. The drought is completely good. So, yeah, good is the new government, they should have good rains.
So that's happens when you say that means the delay of the number of days, the thing doesn't move. How do you define that?
Because the simply saying from the chart, monsoon chart, they put a onset dates like that, progress, how far monsoon has progressed, they put a line. Then they will move only the further monsoon progress happens.
So this line can stop anywhere.
That can happen.
So that is not taken into
It
consideration.
can normally happens along the west coast. When the first phase of monsoon.
No, no. Now it happened over central India and stopped there for 40 days. So that can happen below, above. All those are considered higher risk.
Yes, along the west coast, basically it's south of Bombay. Anything, anywhere it happens, it is counted as.
So, and during the normal climatology, drawing the lines, how does one draw those lines over the region?
This time what we did is we used the rainfall threshold, rainfall criteria using gridded rainfall. And we used this some kind of, Kerala is very easy, the short brace is there. But if you really go in somewhere in Maharashtra, in the other parts of Andhra Pradesh, the short brace will not be seen. So there is a, so if it crosses the threshold beyond the climatological value, and we call it a upset.
That line is.
So we need a degree point of 1 degree by 1 degree. We calculate this dates and this threshold crosses the climatological value.
That data is from the IMD.
It's all IMD. All IMD. It's all IMD. Anybody see, for example, there's one, I forgot his name, Misa, Miami University, which is TNK student.
Misha.
Savashananda Mishra. He has his own online Onset and withdrawal. Again, you put a value and anything crossing. So we can define onset in many ways. But my point is that it should be objective. If you're not, if for example you do it, if somebody else does it, it should be same.
So what is that threshold?
I don't remember the story. You should read that paper, the SARS paper. The IMD's paper is written by Pai, Dr. Shivan Pai, published in Monsoon recently, some 2 years back.
So as you said, the craft is, like identified using the IMD rainfall, right? So over the ocean, so
Over the ocean, that lines are drawn based on satellite photos, satellite images. So I said, right, it's now onset in the first phase, basically it's onset the northern propagation of it is. So over the ocean, the the east-west cloud orientation will start moving in. So you can put the northern part of the northern edge of the clouds, and that is the. And sometimes you get ship observation, you can have wind speed criteria. But normally nowadays they look at the satellite.
So it's basically amalgamation of multiple data sets.
Of course.
Break in the onset which you have shown that hiatus. You have shown that one of the reasons might be that the mid-latitude systems are coming, the high intrusion of the air is coming. So is it because the monsoon has become weakened because of some kind of a tropical phenomenon?
So we don't know. So I'll tell you a very simple and colloquial way. When monsoon, see, when before monsoon, we have all winter system, then summer systems, middle latitude westerlies comes down, subtropical ridge comes down. When monsoon comes, everything will go south. So monsoon comes and say, this is my house, I'll stay here. And the other fellow will say, I'm not allowed, I will go only slowly. And when rain comes, they will come and intrude because you are weak. So monsoon is you are weak, so they will come and intrude your house. So it depends upon how this mutual role is. And of course, as you said, that tropical features and the equatorial features, El Nino, all can have an impact. But middle latitude, in my understanding, is there's a large influence. And when monsoon becomes big, middle latitude things comes down. And when it goes up, they will push and go. I will come and stay. Yeah.
So 1972, which are till now the latest onset, had 0 hiatus. In your plot, that's what we saw.
Yes.
That's the one interesting
Yes.
point. And number.
And I don't remember 1 year, it came very late, not 72, and it covered the whole monsoon in 10 days.
Yeah,
10 days.
okay. Fine. But the second comment is, if this year IMD's onset day is not the real onset, then this year could be the latest onset, even beating 72.
Quite possible.
Yeah.
But you have to prove that I am
So already there, proof is already there.
I am the one admit, but you have to prove it at least I think a research paper that they don't admit.
Yeah.
Yeah, but I have my own doubts. So it came very big. It's not really much to us. But if they declare at 24, 25, I will agree. Because a lot of here, East West stuff was there, Kerala was there, ITCs were very clearly seen. Clearly see the sand food on the end. It was beautiful. So when ITC was stationary there, it was very strong. Then the cyclone formed at the northern edge of this ITC. That's what normally forms. The cyclone forms northern edge of the ITC. That's what actually happened. But once it formed, it moved, then it all got disrupted. So the first when rain which started by 24th, maybe around 22nd, they could have declined.
Yeah.
I asked the IMD people, they say that some reason they told, they say it's not viscosity was not very strong.
Why there was hiatus in the northeast, Assam, northern Bengal, a lot of flood is happening for last maybe 25 days, continuous rainfall and so on.
Yeah.
So it cannot be for the low pressure systems because the range of low pressure is somewhat lower. So what is the take?
See the northeast gets rain because of this southerly flow in the monsoon. You can see the circulation. It goes steadily here, it turns south, and over the northeast is just southerly. That's why Mahabaleshwari, what is called Monsoon and all gets heavy rain because it just peaks in the east-west hills. Just perpendicular. That's why they get a lot of plenty of rain. So there the rainfall dynamics is completely different.
So is there any connection between hiatus and
Could be.
like that?
I think you should study. I don't know. Could be. But this onset over northeast before Kerala, it happens very rarely. But in the past also happen, but it's not very common.
Yeah, online is asking.
Online, someone has raised.
How do you mention?
I to go down.
It's
Not sure.
just hand. I think he was asking or something. I don't know.
MCK. You can ask him. Kalapur Reddy. Yeah, he's from IIT.
Yes, sir. Sir, good evening, sir, and very nice.
Good evening. Good evening.
Thank you, sir. Thank you for this high-test information. You have done it for the almost more thing, and it is goes on 99% increase. So I just want to ask you two questions, sir. One is whether really the monsoon is shifted by 1 month late. For last 3 years, we have been seeing that it is extended up to September and October also. So it is delaying like in July, it is starting and maybe ending in October. Is it like that, sir? I just want you to comment. You are the right person.
Well, let's say the last few years, if you see that your answer is yes, this question is correct. There is a small delay in monsoon onset, especially over central India. And also monsoon withdraws much later now from northwest India. I did not show, I had one graph showing that how the withdrawal from northwest India is changing. There's also a positive trend, so it's getting delayed. But then I'm not very convinced because these dates are from IMD. So IMD's withdrawal dates, I'm not very sure how objectively they define. So sometimes they wait. I can give an example. In few years back, they declared monsoon withdrawal from Rajasthan. Then after a few days, a low pressure system formed. It went up to Rajasthan. So now they are very sure that no low pressure system forms. So before they declare, so there could be another subjectivity. It's for my personal feeling. I'm not questioning IMD, but then we should do it in an objective way using rainfall data.
The total duration may be for like an observation.
The duration also is increasing. Duration.
Yes, sir.
So if you really see the date of monsoon onset and withdrawal, about 113 days are there, and the mean days, and these days the duration is increasing.
Increasing, yes, sir. And that is what your last concluding point. So
I put the concluding point, but I forgot to put that slide.
Yeah, but what we are telling the observational people like we at the central India, we are preparing from May to almost like October end to take observations of the monsoon.
Okay. That's true.
Sir, next question is that this high test information you brought, it goes on increasing. And is it more dangerous at the beginning? That means beginning of the monsoon, if it is high test is there, it affects a lot, or at the ending, because you given early and later. Which one is more important?
High test normally happens in the month of June, early part of the June.
Okay. Thank you, sir.
Thank you, Now, if I to continue.
She was trying to ask questions.
Good afternoon, everyone. I'm Shujatra Bhattacharya. My research supervisor is Professor Arindam Chakraborty. And today I will be talking about that ENSO-Indian monsoon relationship at subseasonal timescales. So in the beginning, I will show this moisture budget framework, but this is for the entire JJS. This is the seasonal part. So I'm taking it from this Chakraborty and Singhai 2021. Where this moisture budget framework works something like this. This is the Indian domain, that ABCD, which you see. And there are 4 boxes surrounding this. These are the pressures, surface pressure or sea level pressure. There are PS1, PS2, PS3, and PS4. So this moisture flux, its direction and its magnitude will be determined by gradients of this. The PS1 and PS2 gradient that will come to this moisture flux will come into this domain. Similarly, PS2 and PS4 gradient will determine the southward fluxes, similarly eastward and northward fluxes. And they have shown that Indian summer monsoon rainfall for this particular domain is mostly showing a positive correlation and very strong correlation about 0.71 with the net moisture flux convergence into this particular domain. Well, another thing is that the precipitable water, the total column integrated water vapor over this particular domain and the infinite you see, it is also showing a quite strong correlation. And at last, the Indian summer monsoon rainfall only over the land regions you just take with the pivot over the land, that also shows a similar kind of a correlation and a very strong correlation. So everything is we can in the seasonal time scale understand this Indian summer monsoon rainfall variability using this net moisture flux convergence. Next, I just wanted to show the El Nino and the La Nina composite years using the same method they have used. And you can see for the El Nino composite years, there is a strong high pressure region is created over this. And similarly in the La Nina years, there is a low pressure region, exactly opposite, but the anomalies are less as compared to this particular strong anomaly over here. And So the gradients based on the pressure gradients, like this this north-south gradient in the westward direction or the north-south gradient in the eastward direction, those things will determine this moisture flux, which is shown here based on this. This is the net moisture flux convergence. That is west minus east and south minus north. That will give you the entire moisture flux over the Indian domain. So based on this, they have shown that this is well valid, that if net, the net moisture flux convergence is actually negative. That means it's diverging during an El Nino kind of a condition or a composites. Whereas in the La Nina kind of a condition, you are finding that it is positive. Maybe this is small because of this. The pressure has not well, I mean, it's not as strong as this, might be because of that. So in the seasonal time scale, this looks very simple and a very simple structure. That's where you can see that this surface pressure is actually playing a role, this westward, this gradient of the surface pressures. But in the subseasonal time scales, when you just look at different months, you find that these pressure gradients tends to vary. And as a result of which, the fluxes also changes. So this is what I have done here is that Nino 3.4 I have taken, and I have regressed it with the surface pressure everywhere in June, July, August, and September. I have taken 2 months average, Nino 3.4, and we can take 3 months average also, it won't matter. So this is the Indian domain, the same Indian domain which I have drawn here. So in the June, you can see that in the northern parts, you have good high pressure anomalies, high surface pressure anomalies, whereas in the southern part it is somewhat weaker as compared to that of the northern part, and that's resulting into the your westward fluxes. The westward boundary fluxes is negative. That is, it is going in this direction. Obviously, following this pressure pattern, it is going in this particular direction. Whereas in the eastern boundary, this pattern is something like this. So that is also negative because you have a high pressure anomaly over here, and as you go southward, pressure decreases. So that results into, again, incoming fluxes into this Indian domain. So FW minus FE, you can see that it is about -7. So, and if you now look at the July kind of a condition, this northward pressure gradients, which the northward pressure anomalies which are there earlier, very high pressure anomalies are there, they exactly get reversed. It becomes negative over here. This is also weaker as compared to the southern parts of the southern parts surface pressure. So this results into change in the moisture flux pattern. You can see that now FW becomes +6, FE becomes +32. It's very strong, particularly because there is a low pressure which is sitting over here. Anomaly is July is mostly similar, but in the September, you find now because there is a strong surface pressure anomaly which is created over here is exactly similar to that of the seasonal scale pattern. It is quite strong over here, and because of that, this FW is becoming negative, but FE, here it is actually, if you go northward, the gradient actually weakens, and as a result of which FE is actually positive. Now it is eastward. So it is eastward, the eastern boundary fluxes are eastward, western boundary fluxes are westward. So that is resulting into strong divergence of the fluxes from this particular domain. And a simple picture can be seen here. This is for the June, the moisture flux due to Nino 3.4 is very weak. But from July onwards, it remains to be high, but in August slightly decreases. September is the maximum. Now, it might be possible that this, if you look at from June to July, August and September, the change might be because it is happening from July onwards. So it might be possible that the diabetic heating over the North Bay of Bengal might cause a role, because if you look at the diabetic heating over the Northern Bay of Bengal, just after the Central Indian onset, approximately 15 June happens, just after that, it becomes strong, and it almost remains up to some 15th of September or so. So this maintaining this diabetic heating profile might be causing a result. So causing this kind of a flip in the pattern in the fluxes, or the changing in the pattern that.
Yeah. 1 year or climatology?
This is climatology.
Climatology.
This is climatology. For 74 years I have taken, this is the climatology. And so we want to see it using some modeling simulation, very basic modeling simulation. We try to see it. This is the hypothesis which we have posed here, that once after the onset of the central India is established, the diabetic heating is very strong over the northern Bay of Bengal. That might result into the ENSO monsoon feedback. Why? Because June, you see that the moisture flux divergence is very weak as compared to any other months. So we started with an aquaplanet setting with CSM CAN 6, 1 degree resolution. This is a controlled experiment where we have seen the SST July condition, but solar symmetric we have taken. And with the June kind of a solar insolation, because we want to reproduce.
It's a chronological one, see?
Yes.
If you plot the rainfall over the same region, how it looks like same thing.
Rainfall, I have not checked the rainfall, but yeah, I have checked the rainfall. I have not seen it.
You average for many years, we are not getting the intra-seasonal state. Because in conceptual Bay of Bengal also has intra-seasonal.
Maybe because of averaging so many years, not like that. Yeah, so this is that condition of the control of the base experiment, which I have made. Based on that, a control precipitation plot is shown here. And this is the moisture flux anomalies. Not anomalies, the moisture flux itself. So you can see mostly stored fluxes over here. Now, the next what I have done is that I have reproduced an ENSO pattern, that El Nino kind of a response, and just put it over that same July kind of a that July control thing, SST pattern, the zonal symmetric SST pattern. Just I have added this particular anomalies with this particular SST pattern, and try to run the aquaplanet that model, and I'm getting some precipitation, something like this, where you can see some negative patches, but mostly these regions are remaining weakly positive. But if you take all over thing, I think it will be all over India. If you take the range, it will be mostly positive. So El Nino kind of a condition is giving the rain positive. Let's see the moisture fluxes and the surface. Yeah.
You must say that the background is not there.
Okay. This is not there. This is aquaplanet thing. This is the imaginary boundary. I just drawn. So now this is the surface pressure and the moisture flux change, that is El Nino minus control. I've shown here. Again, so this is the Indian domain. I have just assumed that this is the Indian domain, because in the next couple of slides I will put something over here, that some not diabetic heating, some heating I will give. So because of that, I have just put it. So just if you see the moisture fluxes over this domain, we find that the FW is negative, FP is slightly more negative than this, and F south is larger as compared to F north, and that results into the F net to be positive. So El Nino kind of a condition alone is giving a net moisture flux, positive net moisture flux over the Indian domain, and that results into positive anomalies of rainfall. But based on our hypothesis, if I put some, I have not put the diabetic heating profile. I will put in the maybe after this in the future. But I have taken some SST heating, basic SST heating I have given using this Green and Hoskins 2004. I have given a 3 Kelvin heating at this 25 degrees latitude and 90 degrees longitude, and added this heating over the. In one case, I have added, this is the BOV experiment, where the SST which I have shown, the July SST, I have added with this SST heating over here, this anomalies. This is one of the cases. Second case, with this El Nino kind of a response, this structure, this SST, I have put the BOV heating with this. So there are two experiments which from here I have taken. One is that only BOV heating with the July climatology condition, and another is the BOV heating plus the El Nino kind of a condition. So what these two will give. So now my control will be now the Bay of Bengal, because we will be trying to look how the Bay of Bengal plus El Nino kind of a that setting will change with respect to the Bay of Bengal, only Bay of Bengal heating. So this is the precipitation which I have just shown as a reference. But now if I take the precipitation for the BOV plus El Nino experiment, minus the UV experiment only, I will get some negative anomalies over the negative precipitation anomalies over this particular region. And if you look at the moisture fluxes, you will find that the net moisture flux is very small but negative, as opposed to what I have found out only when I have put the El Nino kind of a condition, we have got a positive flux. But when I have put the diabatic heating or not diabatic heating, SSP heating over this particular geothermal region, that is giving a negative flux by changing the fluxes pattern slightly. But the thing is that the pressure patterns, if you just see the observation thing, the pressure patterns are similar, but over this region, it has to be shifted over this particular region. Then only we will get, we will represent the actual surface pressure pattern, and then only I think the fluxes will improve, and that results into the net moisture flux. I believe that it will be much more negative. So we have to see that whether any other heating sources like Indonesian heating or Northwest tropical Pacific, are they going to influence this particular net moisture flux convergence or divergence during the El Nino kind of a condition. So this is what I just wanted to show. This is a short experiment which I have tried. But yes, so I will stop it here. Thank you.
Yeah, this is an aquaplant solution, right? So I have a little based on the analytics approach. If you put aquaplant over India, the net flux will be different. So that fundamentally altered your interpretation over India. Okay, that's what you are worried about.
Yes.
Because over India, when only land is there, only energy flux from the top. When you have ocean, you get lots of fluxes from the bottom. Okay. And what is SST over India in your aquaplant? It's
I've given
totally uniform, right?
Yes, this kind of SST pattern I have given. Just only over that northern geographical region, and just over.
I'm coming over India. Over India, you have put some imaginary SST.
Yes.
Right? So you are extending it between interpreting the Arabian Sea and Bay Bengal.
Yes, yes.
Yeah.
Extrapolating
Yeah.
that.
So you have to look. I wanted to calculate evaporative flux from India as compared to climate development of India. It will be very different. And that altered your whole interpretation.
Okay.
So that's why I would prefer you to look at P when a Z. So the E part is removed. So let's look at convergence part only, then it's okay. If you look at P, then additional E over India due to it being ocean. Different. Yeah. So there are no other questions. Let's thank both the speakers today for a very interesting presentation. Next Wednesday is a holiday with Muharram, so we're not meeting. And so we'll meet on 24th. Now, who is talking 24th?
Yes, you asked Deepesh to present.
Huh?
You asked Deepesh to present on
24th. But that's not true. So Deepesh and Deepesh will be online, right?
Online.
Yeah. We'll make it online first so that any problems then doesn't get problem. Okay, thank you. New